Good day. In the second part of Study Unit 4, we are going to continue with Chapter 10 and we are going to finish the last part of Chapter 10. In the second part of Chapter 10, we are going to look at hypotheses that involve population means for small samples, and then also test hypotheses for population proportion. So when we test population proportions, look out for something like percentages or rates, or so many out of so many people prefer something, for instance. And then we are going to use the same 5 steps that we did in the first part, and then you should also still be able to distinguish between left-sided, right-sided and two-sided hypotheses. So we are still going to apply these 5 steps discussed in part 1. So this is the test statistic that we will use to test hypotheses for population means for small samples. So that means a sample size less than or equal to 30, and t follows the t-distribution with n-1 degrees of freedom. So we can use the t-table to determine our p-values in step 4. In example 10.2, they state, a rugby enthusiast claims that on average 5 tries are usually scored in a match. This is then my claimed value, so me 0 will be 5. And then they tell you a random sample of 25 matches. So we are working with a small sample size, so n will be 25. And the mean number of tries per match is 6.2, so that's my x bar. And the sample standard deviation is 3.2, so that will be my s. Then they want to know, does the sample contain sufficient information to contradict the rugby enthusiast statement? So that means in the alternative hypothesis, we just want to test that it's not 5, so our sign will be not equal to. And then they say assume that the significance level is 0.1. And then they state that assume that the population is normally distributed. This refers to the population data, but we still have a small sample size, so that means that we will use the t-table to determine our probability value in step 4 and not the z-table. This is then our given data. Step 1, we state the null and alternative hypotheses. So in the null hypothesis, we state that the population mean is equal to 5, and in the alternative that the population mean is not equal to 5. Step 2, we write down the formula for our test statistic and we state the distribution. Since the sample size is 25, our degrees of freedom will be n-1, so it will be 24. So t follows the t-distribution with 24 degrees of freedom. And our significance level was 0.1. We can then substitute our sample data to determine our t-value. So our t will amount to 1.875. For our p-value, we will look at the probability that t is less than 1.875 plus the probability that t is greater than 1.875 since we tested a two-sided alternative hypothesis. We only have a positive t-table, so we can write the p-value as 2 times the probability that t is greater than 1.875. But remember, in the t-table, the probabilities are only given to the left-hand side of a positive t-value, so we can rewrite that as 2 times 1 minus the probability that t is less than 1.875. And if you look up that t-value in your t-table at the degrees of 24, you will see that that value is not directly given in your table. So it means that t will lie between 2 t-values and your probability will consequently lie between 2 p-values. So we can use the interpolation formula from chapter 8 to determine that probability. So these will be your t and p values that you can substitute into your interpolation formula, and if we simplify, your p-value will be 0.072. If you compare that to your significance level, p will be less than alpha, so we can reject the null hypothesis according to our decision rule. So we can draw the conclusion that the sample contains sufficient information to contradict the rugby enthusiast statement that the population mean is 5 tries. Example 10.3 state that a sample of size 6 is available to test if the mean mass of horses in a large herd exceeds 450 kilograms. So our sample size n is going to be 6, and we are going to test a right-sided alternative hypothesis, so the sign is going to be greater than, and our claimed value is then 450, so that will be our mu0. Then they give you a significance level of 5%, so alpha will be 0.05, and they give you the 6 sample values as follows. So they didn't calculate the sample mean and the sample standard deviation, so you had to calculate that yourself. Our sample mean is going to have a value of 501.167 kilograms, and the standard deviation will be 56.933. Step 1, we state the null and the alternative hypothesis. So in the null hypothesis, we state that the population mean is equal to 450, and in the alternative hypothesis that the population mean is greater than 450. Step 2, you write down the formula for your test statistic, and T follows the T distribution with 5 degrees of freedom since our sample size was 6. And then our significance level will be 0.05. So we can substitute the sample data to calculate the t-value in step 3, so that will amount to 2.201. And then if you look up that t-value at the degrees of freedom of 5 in your t-table, you will see that that value is not directly found in the t-table, so we will again have to apply our interpolation formula. So these are our t and our p values from our t-table. So we are looking for the probability that t is greater than 2.201. So because we only have the values to the left-hand side of a positive t-value, we can rewrite that probability as 1 minus the probability that t is less than 2.201. Then we substitute the values into our interpolation formula, and our p-value will then be 0.04. If you compare that to your significance level in step 5, p will be less than alpha, so we can reject the null hypothesis according to our decision rule. So we can conclude that the mean mass of horses in a large herd will exceed 450 kilograms. You can then try exercises 3 and 4 at the end of chapter 10, please. This is the test statistic that we will use to test hypotheses for population proportions, and Z follows a standard normal distribution, so we can use the Z table to determine the p-values in step 4. In example 10.4, they state a manufacturer claims that 5% of goods manufactured are defective. This is our claimed value. So pi 0 will have a value of 5% or 0.05. Then from the sample data they tell you that 14 of the items were defective out of 200 randomly chosen items. So x is going to be 14 and our sample size n will be 200. And then they want to know, is there sufficient evidence to show that more than 5% of the items are defective? So in the alternative hypothesis, we are going to test a right-sided alternative hypothesis, so our sign is going to be greater than. And then they tell you that the significance level is 0.1. We can use our sample data to determine our sample proportion. So 14 divided by 200 will be 0.07. And in step 1, we state the null and the alternative hypothesis. So null hypothesis will be that the population proportion is equal to 0.05, or you could have said 5%. And then in the alternative hypothesis, we state that the population proportion is greater than 0.05 or 5%. Step 2, you write down the formula for your test statistic, and you state the distribution, so Z will follow a standard normal distribution, and we write down our significance level. Then we can substitute our sample data in step 3 to determine the Z value. So Z will be 1.298, or if we round that off to 2 decimal places for our Z table, that will give us a value of 1.30. So in step 4, we are going to determine the probability that Z will be greater than 1.30. We only have the probability values to the left hand side of a positive Z value in our Z table. We can rewrite the p-value as 1 minus the probability that Z is less than 1.30. So if you look up that probability and subtract it from 1, our p-value will be 0.0968. And then in step 5, we do the comparison. So our p-value will be less than our significance level. So we can reject our null hypothesis according to our decision rule. So in conclusion, more than 5% of the manufactured items are defective. In example 10.5, they tell you, manufacturer claims that his market share is 60%. So our pi 0 will be 60% or 0.6. And then they drew a random sample of 500 clients, and 275 supported his product. So our sample size N is going to be 500 and our X is going to be 275. Then they ask you to test the manufacturer's statement at a 1% significance level. So alpha will be 0.01. We can then first of all determine our sample proportion. So 275 divided by 500 will be 0.55. Then we want to test the two-sided alternative hypothesis because we want to see if the market share is 60% or not. So in the null hypothesis in step 1, you will state that the population proportion is equal to 0.6 or 60%, and in the alternative that the population proportion is not equal to 0.6 or 60%. In step 2, we state the formula for our test statistic and the distribution that it follows, and then also the significance level of 0.01. Then we can substitute our values into our test statistics formula to determine the Z value, and that will amount to negative 2.282. Since we are testing a two-sided alternative hypothesis, we will determine the p-value in step 4 as the probability that Z is less than negative 2.28 plus the probability that Z is more than 2.28. Our p-value will then be 2 times the probability that Z is greater than 2.28, or you could have said 2 times the probability that Z is less than negative 2.28. And then since we only have the values to the left hand side of a positive Z value, we can rewrite that as 2 times 1 minus the probability that Z is less than 2.28, and our p-value will then be 0.0226. If you compare that to your significance level, p will be greater than alpha, so we do not reject the null hypothesis. And we can conclude that the manufacturer's market share is not significantly different from 60%, or you could have said that the evidence from the sample does not contradict the manufacturer's claim that the market share is 60%. You can then try exercise 9 at the end of chapter 10 to test hypotheses for population proportions, please.